Hello, welcome back to Chapter 12, Capital Budgeting. What is capital budgeting? Capital budgeting is the term used to describe the process of determining how a firm should allocate scarce capital resources to available long-term investment opportunities. Because the goal of the firm is to maximize shareholders' wealth, managers are responsible for selecting only those investments that are expected to increase shareholders' wealth. Ultimately, we will be concerned with the comparison of cost versus benefits. The benefits are the cash flows provided by the investment, and the cost is the amount spent to acquire it, or in present value terms. Only projects where the benefit equals or exceeds the cost should be accepted. Making the decision. Once the relevant cash flows have been determined, it's time to calculate the profitability measures. There are 6 commonly used profitability measures: payback period, discounted payback period, net present value, profitability index, internal rate of return, and modified internal rate of return. Payback and discounted payback period. Payback methods answer the question, how long will it take to recoup the initial investment? If the payback is short enough, then the project will be accepted. Payback period start with the initial outlay and then subtract annual cash flows until you get to 0. This method ignores the time value of money, which is problematic. Discounted payback period, same as the payback method, except that we use the present value of the cash flows. This method fixes the time value of money problem with the regular payback period. Note that both methods ignore any cash flows that occur after the payback period, so they may not result in an economically correct answer. The text provides an if statement that can be used to calculate either of these payback methods. You can use the FINA payback user-defined function. Net present value. The net present value is a direct comparison of the benefit of the project with its cost. It's calculated as the sum of the discounted cash flow minus your initial investment, which is the benefit minus your cost. Excel has a net present value function, but be aware that it actually calculates the present value of uneven cash flows, not the present value. So use it to calculate the first term above, and then subtract the initial investment. The project should be accepted if net present value is greater than 0. Profitability index. The PI is a profitability index, is closely related to net present value, and it's also a direct comparison of benefits and costs. But it's a ratio instead of the difference. It's calculated as the sum of the discounted future cash flow divided by your initial investment, which is the benefit divided by your cost. The project should be accepted if PI is greater than 1. Internal rate of return, IRR. The IRR provides a measure of the compound average annual return that a project will provide. The IRR is the discount rate that makes the net present value equal to 0. If IRR is greater than WACC, then the project will be accepted. Because it's a measure of the percentage return, many analysts prefer to be other methods that have discussed. The IRR cannot be calculated directly. We have to use the trial and error method. Excel has the IRR function that will do the trial and error calculation for you. The IRR has several potential problems, including that there can be more than one IRR, which renders it unusable when a project has non-normal cash flows. Modified internal rate of return, MIRR. One of the drawbacks of IRR is that it assumes that the cash flow will be reinvested for the life of the project at the IRR. Particularly for projects with a high IRR, this can overstate the actual rate of return that will be earned. A better assumption would be that the cash flows will be reinvested at the firm's WACC. And this is the assumption made by MIRR. If MIRR is greater than WACC, then the project should be accepted. The MIRR can be calculated as in the following equation. Excel has an MIRR function that will do the calculation for you. Note that both rates that it requires should be equal to the WACC. NPV Profile Charts. An NPV profile chart allows us to visualize how sensitive the net present value is to the WACC. In other words, how the net present value changes as the WACC changes. Typically, as shown in the image at the right, an NPV profile chart is used to compare two projects. We simply calculate the NPVs of each project at many different WACCs and create a scatter plot. There are a couple of important points on the chart. The crossover rate, where the NPVs of projects are the same. If the WACC is less than this rate, then one project is better, and vice versa. The IRR of each project is where the NPV profile line crosses the x-axis. That is where NPV equal to 0.